Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Good morning, students. We are going to see about data structures. Okay. So these are the topics that we are going to cover in the first unit. And first we are going to see, before going into the syllabus, let's see what is data structure. So what is data structure? Data structure in the sense, it's a way of collecting, organizing, storing, processing and retrieving data from computer memory so that it can be used effectively. So what does it mean? So in the sense, if you want to perform anything, we need data, right? So that data should be organized in such a way so that it can be effectively used for processing. So in our computer memory also, if you want to do something with the data, at first you have to collect the data and then you have to organize the data. For what purpose we are going for this organization in the sense? So if we organize the data properly, then for the processing, it will be easy to access the data. So that's why we are going for organizing. Then that data should be stored in such a way. Okay, it may be stored in the form of array or in the form of list, whatever it may be. Okay, so the data will be stored. Then the necessary processing will happen. I mean, in simple, we can say the processing may be addition or subtraction, some kind of evaluation. Okay, so after the process, the result should be retrieved back. Okay, so for that purpose, we are going for this data structure. Okay, and you know that if you are having 10 elements of same data type, we all know that actually we will go for using which data type? Definitely we will go for using array data type. Why we are going for using this array data type? The reason is array can be defined as a collection of homogeneous data items. So array can be used to store data of same data type. So in your hand you are having 10 data items of same data type. For example, it may be of integer data type. So definitely you will go for using this array implementation. Okay, so this is an example. So this is an example of an array. Okay, so this is an example of array. So here in this array we are having 7 elements have been stored. Okay, another one thing you should note, in our array all the elements will be stored in contiguous manner. Then so we can say that we know about array, so we can say the simplest data structure is one dimensional array. So here the data will not be stored in contiguous manner. Okay, so in case if the data are not stored in contiguous manner, in the sense they will be linked with the help of pointers. Okay, so for storing the data efficiently we are having various algorithms. Okay, so that we shall see later one by one. Next, this is the classification of data structure. So data structures can be classified into primitive data structures and non-primitive data structures. So primitive data structure, under this we have integer, float, character, pointer, string, everything comes under primitive data structure. And under this non-primitive data structures we are having arrays, list and files. Okay, again under this non-primitive data structure, list will be classified into linear list and non-linear list. So again, this linear list is classified into stacks and queues, and non-linear list is classified into graph as well as tree. Okay, so this is the classification of data structure. So here keep in mind that we are having linear as well as non-linear data structure. Under the linear data structure, we are having stack, queues as well as list, and under non-linear data structure, we are having graph and trees. Okay. Now, so before seeing the data structures in detail, we should know abstract data type. So what is mean by the term abstract? So data type, you may be aware, in some other programming languages you would have come across this word data type. But what is this abstract data type? Abstract, simple. Abstract gives summary of something. For example, if there is a film, if you go for reading the abstract, that two and of our film will be summarized in a single paragraph, right? It may be of 20 to 25 lines. So similarly here also, abstract in the sense we are going to summarizing something. So what you are going to summarize in the sense, so listen, if you are going to write a program in the sense, at first you will declare what are the data types, data you are going to use, and what are the operations you are going to use. But there won't be any detailed implementation of the operation. So that's what we are going to see in this abstract data type. Okay. So if you want to solve a problem, we need data, right? So if you want to process the data, we need to define the data types as well as the operations. What are the operations that we are going to perform on this data? Okay. So here abstract data type in the sense we have to declare the data type or data type as well as data and operations. Okay. So so it gives an implementation independent view. What does it mean? It just gives the detail about what we are going to do and not how we are going to do. Okay, so that is called as abstract. So we can say the definition of abstract data type is it's a mathematical model. Just a model will be there. So it's a mathematical model together with set of well-defined operations. So this is called as abstract data type. So here it does not mention how we are going to implement. So some of the examples of abstract data type are list, set, graph, then stack queue. What are the things? What are the data structure you are going to study? Everything comes under abstract data types. Okay. Now let's see the advantages of abstract data types. So code reusage is possible. It's easier for maintenance. Achieves modularity. So what is meant by the term code reuse? So instead of writing the code from scratch, so if we have the abstract data type, then it will be possible for reusage. Then easier for maintenance in the sense, so in case if you want to perform any debugging, it will be easier to debug. And achieves modularity. What is meant by the term module? Module in the sense some set of function will be there. That function will do the predefined task. That is called as module. Then let's see the disadvantages that we are having in abstract data type. So in case of abstract data type, the main disadvantage is, so if the same function has been or same operation has been called again and again, then overhead is going to occur. That is the main disadvantage in abstract data type. Okay. So next we are going to see about our list abstract data type. Okay. So list. So you know that what is the general form of a list? The general form of the list is, you know that you will be having some set of data that is called as the list. So here for our easier understanding purpose, we have returned the general form of list as A1, A2, A3 up to AN. Okay. Here the size of the list is N. So if there is no element in the list in the sense, then automatically we can say the size of the list is 0. Okay. And now so if in the list we are having some set of elements, right? So there will be predecessor and successor. So what is meant by the term predecessor? Predecessor in the sense previous element, and successor in the sense the next element. So predecessor, so for example, if you are assuming the element as AI, so here let's take this element, okay? So who is its predecessor? Its predecessor is A1 and its successor is A3. So previous element will be called as, this is AI, and your previous element can be called as AI minus 1, and your next element or the successor can be called as the AI plus 1. Okay. Then here the first element in the list is A1 and the last element in the list is AN. Okay. So if the position of an element is I. Now let's see what are the operations that we can perform on this list ADT. Okay. So some of the operations that we can perform on this list are print list, then make null, find, insert, delete, find kth. Okay. So print list, from the name itself you can say it is going to print all the elements in the list. Okay, that is print list. Then make null in the sense this is going to delete all the elements in the list and it is going to make the list as null. So that's the use of make null operation. Then next is find operation. What is the use of find operation? This find operation is used to return the position of first occurrence of a key or the element that we are going to, whose position we want to know, that is called as key here. Okay, so here in the list there may be a duplication of elements. So duplication of elements is there in the sense, so the position of its first occurrence will be display or will be retrieved with the help of this find operation. Then insert operation is used to insert the element into some specified position. In which position we are specifying, there the new element is going to be inserted. Then delete operation. What is the use of this delete operation? So this is used to delete some element from the list. Then find kth. This element is going to return the element in some specified position. Okay. So these are some of the operations that we can perform on the list. So look at this example. So consider we are having 5 elements in the list. Now we are going to perform find operation on this list. If you write like this, find of 52. So what it is going to do? It is going to, as you know that find operation is used to retrieve the position of an element. Now we need to find the position of this element 52. So look at this list. In this list 52 is present in the position 3. 1, 2, 3, right? So we are getting the output as 3. Okay, so this is the use of find operation. Then insert of x comma 3. So what is this insert of x comma 3? We are going to insert the element x in the position 3. Okay, so if a position has been specified like this, so the new element is going to be inserted after this specified position 3. Okay, so the new element x is going to be inserted after 3. So here in position 3 actually we are having the new element 52, and after this 52 x will be inserted. Okay, then delete of 3. So this 3 specifies the position. Okay, so the element in position 3 is going to be deleted. So actually in our previous list we are having the element 52. So in that element is going to be deleted. So our new list is like this. Okay, then find kth. So what is the use of this find kth? This element is going to retrieve the element in the specified position. We are going to retrieve the element which is present in position 4. So this is our list now. So in the fourth position we are having the element 16. So that will be retrieved. Okay, so this is the example of how the operation of list is being performed. Next we are going to see the array implementation of list. Okay, so before that I should tell, so this list can be implemented in 3 ways: array implementation, linked list implementation, and cursor implementation. So we are going to see about this array implementation in detail. Okay, so what is array? as you all know that array is a static data structure that has a collection of homogeneous data items. Okay, so here which represents all the elements will be stored in consecutive or contiguous memory locations. Okay, so if you specify like this int a of 10, this specifies in memory as the data type is int. For storing a single integer data we need 2 bytes of memory, but here we are storing 10 integer data, so definitely we need 20 bytes. Okay, so 20 bytes of memory is needed. Now, so in the memory allocation, 20 bytes of memory will be allocated for storing the list. Here we are saying this array is static. So can't we make it as dynamic? Yes, we can make it as dynamic also. Okay, so dynamic in the sense inside this no need to specify the size. Okay, so whatever it may be, if dynamic allocation is also possible, then we have to estimate the maximum size of the list. So we have to estimate the maximum size of the list if we go for dynamic array allocation. Okay, so when you go for overestimation, this is going to waste huge space in the memory. Sometimes we may store only few elements, and in the memory we will go for maximum overestimation of memory. So because of this, so memory is going to be wasted. So that is the disadvantage we are having in array implementation of list. Okay, so already we have seen about the operations that we can perform on this list. So here, if we implement the list using this array, the operation find as well as print list will be carried out in linear time. So what is meant by the term linear? So if you are going to print 5 elements, that is actually going to take 5. Okay, the running time we can say in simple we can say 5 milliseconds. So similarly, find in the sense based on if you specify the position, it is going to look at only that specified time. Only it is going to search in that particular position. Okay, so we can say this operations will be taken out in linear time. Then find kth, this operation will take constant for whatever element you want to do, that will take only constant time. But in this array implementation of list, insertion as well as deletion are very expensive. Why we are saying this is very expensive in the sense? So listen, if you want to insert an element at position 0, so we are having 10 elements in the list, and now we are going for inserting element at the front of the list, that is at the position 0. So what will happen? All the elements have to be pushed down to one spot, and a new cell will be created. No new in a new cell will be, we are getting a blank cell. So inside that blank cell only the insertion is going to take place. So before making this blank cell, all the elements have to be pushed down. Okay, so for this operation it take big O of n times. Okay, so whatever it may be, so this is in case of inserting an element at the front of the list. Sometimes if you want to insert an element in the middle, so what will happen? Half of the elements have to be pushed down. So whatever it may be, it is somewhat expensive. Okay. So for in case of deletion operation also the same thing. So for deletion operation we have to pull up all the elements to one spot. If you delete one element, in the sense all the elements which are present down will be moved up. Okay, so we can say that insertion and deletion are expensive in array implementation of list. Then let's see how this list is being implemented with the help of array. So before that, first we have to create a structure. Okay, so for writing or for representing all the integers or all the data items, we have to declare a structure first. So this is the uh, s- so this is the way of declaring a structure. As you all know that a structure begins with the keyword struct followed by structure name. So here we are going to write the structure for the list. So that's why I have mentioned the structure name as list. Then open curly brace, then array name, then maximum number, then int n, which represents the size of the array. Okay. Then let's see how we are inserting an element in the list. Already we have told that this insertion as well as deletion operation are very expensive. So let's see how the insertion is going to happen. Okay, now, so this is the example. So in the array we are having 4 elements. Now we are going to insert an element 2 at the front of the array. So what will happen if you want to perform the insertion operation? At first we have to push down all the elements to one spot. So 12 in this position, that is already it is in position 3, that will be pushed to the position 4. Then the element in position 2, it is moved to position 3. Then the element in position 1 is moved to position 2. Then the element in position 0 is moved to position 1. So we have got a space here. Then after getting this space, we are inserting the element 2 in position 0. Okay. Now, let us consider we are going to perform insertion operation. We are going to insert the element k in position 3. Already I have told that if you specify a position like this, after this specified position will be, the new element will be inserted, right? So here this 3 will be inserted after 3. That is, the element k will be inserted after the position 3. So after the position 3, so here, so instead after the position, here they have inserted the element in that position itself. So after that, from the position 3, all the elements have been pulled down, and after this a space has been created in position 3. So here we are inserting the element 3. Okay, so this is the list after insertion. So here we are making a space, and after that we have inserted the element k. Okay, so this is the routine for inserting an element in an array. Okay, so before inserting an element, first we have to check whether the size of the current size of the array has reached the maximum size. In case if the condition fails, we can go for performing the insertion operation. So before performing the insertion operation, first we have to pull down all the elements, right? So for that purpose only this line has been mentioned. Okay, a of I plus 1 equal to a of I, which represent this line is used for pushing down all the elements. Then a of POS equal to num, which represents at the specified position the number has been inserted. Okay, the next is deleting an element. Okay, so if you want to delete an element, so in two ways we can do this. Okay, first thing is, first will, in practice if we delete an element, this will make a gap. Okay, so so what will happen in the sense, we can delete the element, or we have to shift up all the elements to one spot. So this is the example. So we are going to perform deletion operation in position 3, that is at the position, the element present in position 3 will be deleted. So here in position 3 we are having the element L. So in this we are going to perform the deletion operation. So once you perform the deletion operation, the element present in 4th position will come here. Then the element in 5th position will move to 4th position. Then the element in 6th position will be moved to 5th position. Okay, that's what it is shown here. So this is the list after deletion. So before deletion the size of the list is 7, and after deletion the size of the list is 6. Okay, and this is the routine that is used for deleting the element in an array. Okay, so that's all. So thank you. So with this we can wind up the session.